I'm really excited about this video because this time I was actually out in the field with my colleagues. We are investigating whether bats can self-medicate when they get sick by changing the diet, which honestly sounds kind of wild. Today I'll show you how we catch bats in the Panamanian rainforest, examine them and design experiments to study their eating habits. So roll the intro, let's go! So to study bats, we need to go somewhere where they actually live, which doesn't narrow it down so much since bats are basically everywhere. But we also need proper research facilities, so in our case it is Gamboa in Panama, which is a pretty remote place next to the Panama Canal. Step 1 is obvious: catch some bats in the rainforest. That's usually done with nets that are set up for a few hours, or sometimes just by hand. I was actually pretty surprised when I first joined the team to catch some bats, because we just stopped at this tunnel, which is basically a drainage pipe under a small bridge. But inside that hole, a colony of bats. So down we go, together with Camilo, Nair and Angelis, who are very experienced in catching and handling bats, as you will see in a second. Once inside the tunnel, I was completely blown away by the scenery.
Oh wow!
The three of them in the darkness, silently hunting bats with their nets. It felt surreal. And it didn't take long until Camilo had the first one in the net. You got one?
Yes. So now just, because we have nitrile gloves, we don't need any more for this species because of the size.
He starts with the basic screening. Species, sex, and if female, is the animal pregnant?
This is a Glossophaga. This is not what we are interested in, so we let them.
In this case, wrong species, so the bat is released right away. Meanwhile, Nair caught one of our target species.
So this is a female, Carolia perspicillata,
Okay.
the species we would like to work with.
Yeah. And let's just stop here for a second. How can an animal be this unbelievably cute and, let's be honest, weird at the same time? Quick disclaimer: nothing happens to the animals. Obviously, it's not a great experience for them to be caught and handled, but they're not physically harmed in any way and are released at the exact same location after the experiments. The catching continued. Here's Nair securing another one.
Wow! Nice catch.
It may look a bit rough, but Nair knows exactly what she's doing to keep the animal safe. If it's the wrong species or a pregnant female, it's immediately released. Otherwise, it goes into the bag. Can we just pause for a second to appreciate how insane this is?
Looks like a fucking horror movie.
Within 48 hours, I went from my regular life, being a computer scientist, to being in a tunnel in rural Panama watching this unfold. And also, I'm not sure Camilo brought the right shoes for this trip. After about 30 minutes, we had caught all the individuals we need. The bats were in their bags, time to bring them back to the lab. There they are, waiting for their checkup. Camilo begins with the basics: weighing the bats,
This bag is 33 grams.
Measuring their body proportions, and determining sex.
Check, we have a female. It's a non-reproductive female because we see no appearance of the nipples.
So is there a risk of injury for the animals during this procedure?
If the person is not trained well, could easily break the forearms or the fingers of the animal. when people, right now I just place my finger below the jaw, that way it cannot bite me, and I just hold it. I like to say that you hold it like you would hold a baby, you hold it steadily, but not too strong, because you might hurt the little guy.
For longitudinal studies, we also need to know whether we've caught a bat before. That kind of longitudinal data is super valuable. It gives us insights into individual life histories. One method is tagging the animals, either with bands, which can be really harmful to the animal, or with microchips about the size of a grain of rice implanted under the skin with a needle. This also looks very invasive, even though it usually doesn't harm the animal. Still, it is invasive and expensive, so we try to avoid it. Instead, we've developed an alternative. We take high-resolution scans of the bat's wings. These scans help us identify individuals, kind of like a fingerprint. Here's what one of those scans looks like. And here's the same bat 6 months later. You can see that some features have changed, but the overall pattern is still recognizable. This way, we are able to detect recaptures in our studies. Another interesting fact is that the metabolism of bats is incredibly fast. They burn energy so quickly that they need to eat constantly to avoid starving. That's why they need to be fed regularly during the experiments.
It's fine.
It's fine, yeah.
To test whether bats can self-medicate, we needed the right fruits, ones that might actually help them fight off infections. Since these aren't your typical supermarket fruits, we turned them into standardized portions, basically little bat gummies made from fruit pulp. In the flight cage, we set up our cafeteria experiment. Real fruits on top and gummies next to them. Because bats rely on echolocation, having real fruit shapes was key to triggering natural foraging behavior.
Bye-bye.
Then we watched. What did they choose? Now that's the cliffhanger I'm leaving you with, because that's where my field season ended. There's still a lot to optimize. For example, right now the bats actually still prefer the real fruits, even though we glued them down over our gummies. Over the next few years, the team will return to Panama again and again, refining the experiments, gathering data, and getting one step closer to answering our question. Can bats actively treat themselves when they're sick? Thanks for watching, and subscribe to the channel to hear the answer as soon as we find it.